So why we're doing this then is that this will, with my microphone, it won't pick you up, but if you talk with the iPad, it definitely will hear you. So, all right. So we're going to do talk about a couple other things today about matrices. Something that's called determinants and Cramer's rule. And the reason that we deal with these determinants and Cramer's rule is it's going to give you another method for solving systems of equations. So we did graphing systems of equations and doing substitution and elimination. Cramer's rule gives you another way to solve systems of equations. And then on Friday, I'm actually going to give you one more way. Okay? So, first of all, so determinant is the first thing. Every square matrix, okay, there's square matrices, either 2 by 2, 3 by 3, 4 by 4. Every square matrix has an associated value called its determinant. And the determinant is shown by straight line brackets. So what does that look like then? Absolute value. Okay, so instead of putting brackets, you're going to have just a straight line, so it's kind of going to look like absolute value. It doesn't mean absolute value, but it kind of looks like it. So the determinant of a 2 by 2 matrix can be found by doing this. So we're going to take the diagonals, multiply them together, and subtract. So you take the upper left, lower right, multiply them together. The lower left and upper right, multiply them together, and then you subtract. So it'll be like this right here. So if we call those A, B, C, and D, then we're going to multiply A and D together, C and B together, and subtract. And that gives us what's called a determinant. So, for letter A then, to find the determinant, I have new colors too, I figured out this morning. So if I take those creative things down here and I make them smaller, I have really cool colors. So we're doing, it looks like absolute value, 1, 5, 4, 8. But what we're doing with those numbers then is we're going to multiply 1 times 8 and 4 times 5, and we're going to subtract them. So 8 minus 20 is negative 12. That's a cool color, isn't it?
Yeah. Try the rainbow one.
That is a rainbow one.
Oh, it is? I thought that was the blue stripe.
Okay, so let's do letter B here then. So we're going to multiply to find the determinant. We multiply the diagonals, 1/2 and 2. And the other diagonals, negative 1/2 times negative 1. And we subtract them. 1/2 times 2 is 1. And 2 negatives is a, so minus 1/2, so this equals 1/2. So to find the determinant, you multiply the diagonals together and subtract. Okay? When it's a 2 by 2. Now, determinants can be used for solving system of equations. Make it mine?
Yeah, it really is.
I figured it was, since nobody else contacts you. So. All right? So, we want to solve a system of equations. And so, for a system of equations, we're going to focus on the coefficient of x and y. Okay, so we're going to use what's called the coefficients matrix. Okay? A sub 1, B sub 1, A sub 2, B sub 2. Okay? The coefficients of x and y. The coefficient matrix for a system of linear equations in standard form is a matrix formed by the coefficients for the variables. Now, we're going to use this and the determinants, the coefficient matrix and the determinants, to solve the systems of equations. So to find x, what we do is we have our constants here, C1 and C2. And to find x, we're going to replace the coefficients of x with the constants and keep the coefficients of y. And we're going to divide that by the determinant. And what this is, you guys notice that these are straight lines here, right? Okay, straight lines mean what? You find the answer by, just like you would the determinant, multiplying diagonally and subtract. So notice, once again, that to find x, they've replaced the a's with c's. To find y, the coefficients for x are still there, but they replace the coefficients for y with the constants. And then whatever number they get there, doing the determinant, so to speak, we're going to divide that by the determinant. And we can also use Cramer's rule to tell whether the system represented by a matrix has one solution, infinitely many solutions, or no solution. So if the determinant is not equal to 0, there's one solution. What would be a problem if the determinant was equal to 0? What would be the biggest problem there? Because notice the determinant is in the denominator here, right? And if that equals 0, we can't divide by 0. Okay, so that would be a problem. Okay. So if the determinant ends up being 0, and at least one of the numerator determinants is 0, then you have the same lines and infinitely many solutions. If d is 0 and neither of the numerator determinants is 0, then you have inconsistent system and no solution. Those are parallel lines. So we've learned how to do that stuff a couple different ways. Here's a way when we're talking about matrices and Cramer's rule. And no, that's not Cramer from the show. Sorry.
I was thinking Gibson.
It's not from
That's why he's so good at
You were
math.
thinking of Gibson Cramer?
Is that why he's so good at math? 'Cause
Could
he's
be.
unbelievable.
Right, could be, except his name's spelled with a K,
Oh,
not a C.
so he's more like Cramer.
So, what we're going to do then is, first of all, we're going to make our coefficient matrix. Our coefficient matrix is 2, 1, 3, -2. This is the coefficient matrix. And we're going to use that matrix to find the determinant. So we need to find D, the determinant. So we're going to multiply the diagonals and subtract. 2 times -2 minus 3 times 1 is equal to -7. The one thing that's nice about Cramer's rule, and you'll find this when we get on Friday when we use matrices, a different way of using matrices to do it, is that if you end up with fractions, it's not that big of a deal. Where when we were solving using substitution and elimination, if you got a fraction or a decimal for x or y, finding the other value actually became harder to do it, just because plugging in a fraction in was a little bit more work. But in this case, when we get a fraction, it's really not a big deal. So now, to find x and y. So to find x, we are going to use our coefficient matrix in the numerator, except we're going to replace the coefficients of x with the constants. So we've got, in the numerator, we're using the determinant notation. We replace the coefficients of x, so we're replacing 2 and 3 with 10 and 8. And then we keep the coefficients of y, 1 and negative 2. And then the determinant goes in the denominator. To find y, we use the numbers for x, 2 and 3, the coefficients for x, and we're going to replace the coefficients of y with the constants 10 and 8. And then that's divided by our determinant of negative 7. So because we're using those vertical lines, we're actually going to calculate the determinant of those new numbers. So we have 10 times negative 2 minus 8 times 1 over negative 7. Two times 8 minus 3 times 10 over negative 7. So we're multiplying these two, those two, subtracting. Multiply these two, those two, and subtract. So we get negative 20 minus 8 is negative 28 over negative 7. $16 minus 30 is what? Negative 14 over negative 7. So my answer then is going to be 4, 2. Of course, like everything, the first time I do it, a little bit lengthy. But if I check it, in the first one here, 2 times 4 is 8. 8 plus 2 is 10. Works. 3 times 4 is 12. 12 minus 2 times 2 is 8. So it checks in both cases. So we're basically using the determinant twice to find the values of x and y. Now once you get the hang of it and see it, then you say, okay, that's really not so bad, I can do that. So let's try another one. So when you look at this one, 3x plus 5 equals 2y. And 15 minus 6y equals negative 9x. What's the first thing I need to do? 40?
I don't know how to say, but like you have to move 15 to this side and then.
Okay. So they're not in the right order, correct? Because we've got to have it written as, it has to be written ax plus by equals c. They have to be in that order. If they're not in that order, then you can't do it using Cramer's rule. So the first thing I've got to do is move things around so it's in the right order. So let's see, so I need to subtract 2y, right, in the first equation, and subtract 5 to get to the other side. So we have 3x minus 2y equals negative 5. In the second equation, we need to add 9x, because we need to add 9x to both sides, and subtract 15. So 9x minus 6y equals negative 15. Now, I'm going to go ahead and do this problem, but I already know that these are the same lines. Okay? That this is going to have infinitely many solutions. And I see Dylan shaking his head, nodding his head. So why, Dylan, are these the same lines?
You divide the bottom one by 3 equals the same thing.
Good. Okay. So we know that this is going to be a consistent, dependent scenario as far as classifying it, and they're going to have infinitely many solutions. So let's go ahead and do it so that you can at least get in the practice of putting stuff together then. So my coefficient matrix, 3, negative 2, 9, negative 6. And so I'm going to use the coefficient matrix then to find the determinant. So D equals 3 times negative 6. Okay, we're going diagonally from right to left down. Minus 9 times negative 2. So we get negative 18 plus 18 equals 0. So my determinant is 0, so that tells me right away then that either they're consistent, so I have, and dependent, or I have infinitely many solutions, or they're inconsistent and I have no solution. So I need to check my other determinants to find out which one it is for sure. So for x, we replace the x coefficients with the constants. So this will be negative 5, negative 15, keep the y's, negative 2 and negative 6, over 0. For y, we replace the y's with negative 5 and negative 15, the constants, and we keep our x's, 3 and 9. So we already know we can't divide by 0. It just depends on what happens in the numerators. So it says up here that if the determinant is 0 and at least one of the numerator determinants is 0, then there's infinitely many solutions. So it doesn't have to be both, it just has to be one. So all we really need to do is check for one of them. So for x, negative 5 times negative 6 minus negative 15 times negative 2. So we get 30 minus 30, which is 0. Don't even have to bother with y, and there are infinitely many solutions. Does that make sense? All right, you can see where you're moving things around, okay, to be able to use that. Okay. All right, we have one more thing to do then. find the determinant of a 3 by 3 matrix. Now, if you look in the book, and I guess I didn't put it up here, but if you look in the book for finding the determinant of a 3 by 3 matrix, so I'm going to show you what that looks like. It actually gets a little complicated. We're almost there. With a 3 by 3 matrix, okay, this is actually a lot more complicated because what happens is, because of doing work with diagonals, I actually have to rewrite A and B off to the right here. So because of how complicated that is, I'm going to show you how to use your calculator to do the determinants of a 3 by 3. Okay? If you want to learn how to do this, you're more than welcome to, but I'm going to show you with your calculator. So here we have this 3 by 3 matrix, and go ahead and put that in your matrix A. So second x inverse. So we'll go to matrix A, over to edit, and it's a 3 by 3. 2, 4, 1, 5, 2, 3, and 1, 4, 8. So we go to, we type our matrix in, 3 by 3 matrix, and quit, so we clear it so you're ready for the do determinant. Now go back to your matrix home screen. Back to the matrix home screen, and then over to math. And that very first one says DET. And that's for finding the determinant. And so then I just need to put in matrix A.
Close the parenthesis.
You shouldn't have to close the parenthesis. Hit enter, and we get negative 122. So the determinant for this matrix is negative 122. Oops. So to find the determinant of a 3 by 3 matrix, it's as simple as that. Okay. All right, so that determinant's pretty easy with the calculator. Find the determinant of a 2 by 2. That's not too bad, a little multiplying and subtracting. You just have to make sure you're doing it in the right order. Cramer's rule. Doing determinants, making sure numbers are in the right order. Any questions? All right, so your homework is 2 through 12 on, I think they're just on page 274. So,
Yeah.
okay, Natalie, you